Study guide for test 1, unit 6. All right, so find the value for the variable that makes the equation true. So the square root of 5 times the square root of 5 is the square root of 25. So therefore y would need to be 5. For number 2, it's best to work kind of right to left. So we have 8 to the negative 1 over 7 to the negative 1 if we use our exponent property. And to make an exponent positive, we would shift the position. So now we would have a 7 over 8, each to the first power. They don't really matter. So therefore, n is 7, m is 8. All right, continue with the same type of problems. This time we need to figure out what this k value is. So I can see that I need to rewrite this as a radical. So first I look to see if the denominators are the same, and they are. So combining these two will be pretty easy. So I'll have 7 to the 5 over 10 plus 3 over 10. That's going to give me 7 to the 8 over 10. Now I notice that the index is 5, but currently my index is 10, and that's because I can reduce this fraction. So I'll have 7 divide top and bottom by 2, so I would have 4 over 5. So as a radical, this would be the fourth root of 7 to the 5th. So therefore k would be 5. All right, looking here, I have x to the 4th raised to the n power, which means I would need to multiply those together. And over here, I have myself a 12. But it started in the numerator and then moved to the denominator, which means this would need to be a negative 3. That would allow this numerator up here to be shifted to the bottom to make it positive, which means down here where I have y to the m, and then on top I have y to the 5th, the m would need to be y to the negative 5 for it to be up top. So the m needs to be negative 5, and the n needs to be negative 3. All right, it says use any method, simplify each expression, show your work for partial credit, and use absolute value signs when needed. So here, you can use any method you desire to use. I'm going to just try to simplify the radical. So one thing to realize, this is question 5, so 5 dot. This is not part of the actual question itself, so I'm just going to kind of scratch this out so we don't accidentally use that. It's just meant to be question 5 on the study guide. So we're going to break down 729. So I'm going to go to my calculator and I'm going to divide it by 3. So I notice that 3 times 243 is 729. 729, okay, so 243 divided by 3 is 81. So 3 times 81 is 243. 81 is 9 times 9. And 9 is 3 and 3, and 9 is 3 and 3. So I've broken it down, and remember, every time you break down the number, that number is no longer there once you break it down into the next number. Now, my index is 3, which means I need 3 of the same number to create a circle. So 1, 2, 3, 1, 2, 3. So now we have 3 times 3. Each 3 represents one of the circles. All right, so I have 18 x's. So once again, since I have 18 x's, you could write out 18 x's, which I'm going to do here. 1, 2, 3. This is 6. This is 9. This is 12. 15. 18. 1, 2, 3, 4, 5, 6. Yes, so I have 18. So 1, 2, 3, 4, 5, 6 circles. So I have x to the 6. Now that's kind of annoying, so we can actually take a shortcut. What we could do is say, well, use rational exponents. 12 divided by 3, 12 over 3, which really gives us y to the 4th. So technically there would be 4 circles for the y's. Right? There was everything was circled, so there was no radical left over. Just need to put it all together. 3 times 3 is 9, x to the 6, y to the 4th. It does say use absolute value signs when needed. Since the index was odd, I don't have to worry about absolute value signs. So there's my answer. All right, so for this one, once again, I'm going to kind of cross out this question 6 so you don't see that number. And we're going to break down 192, which is going to be 2 times 96. 96 is 2 times 48. 48 is 6 times 8, which is 2 times 3. 8 is 2 times 4, and 4 is 2 times 2. And once again, when you break down a number, that number is no longer here. Now, we do have an index of a 2. It's invisible, so if you don't see the index number, it's really a 2, which means I need 2 of the same number to make a circle. So I have 3 circles, 1, 2, 3. Each of these 2 represents one of the circles. We have a 3 that did not get circled, so it's going to go inside the radical. I have 6 x's, which would make 1, 2, 3 circles, x to the 3rd. I have 5 y's, 1, 2. So I'll have 2 circles and 1 that did not get circled. So now I'm going to clean it up. 2 times 2 times 2, that's going to give me 8 x to the 3rd, y to the 2nd, square root 3y. Now remember, the directions do say use absolute value signs when necessary. We have an even index, which means I need to check for my variables. If any of them have an odd exponent, it should have absolute values to ensure that you'll get the principal root. All right, so we're going to be simplifying and use absolute value signs when necessary. So for this one, problem 7, once again, I'm going to kind of cross out the 7 so we don't mistake it for being part of the problem. We're going to do 250 divided by 2. That's going to give us the cube root of 125. Our index is a 3. When we are dividing, we're going to subtract the exponents. So we have b to the negative 5 minus 4. And we'll have y to the 15 minus 2. We're then going to get the cube root of 125, b to the negative 9, y to the 13. Since we have a negative exponent, I'm going to move it to the denominator to make it positive. So I'll have 125 y to the 13th over b to the positive 9. Now I'm going to simplify the numerator and denominator. So we have the cube root of 125. That's 5 times 25, and 25 is 5 times 5. So we have 3 5s, and so we will end up having a 5 outside of the radical in the numerator. We then have 13 y's, 1, 2, 3, 6, 9, 12, 13. 1, 2, 3, 4. So 4 y's, y to the 4th will go outside for 4 circles. And then we're going to have the third root of y. On the bottom, we have 9 b's. So 1, 2, 3. So we'll have b to the 3rd in the denominator, with the radical sign gone because there's nothing left on the bottom that didn't get circled. And since we have an odd index, we do not have to worry about absolute value signs. Problem 8. Once again, I'm going to cross out this. This just means problem 8. Going to go ahead and do the dividing. We have the 4th root, and then 80 divided by 5 gives us 16. We got x to the 15 minus 3, and we have y to the negative 2 minus 2. So we're going to have the 4th root of 16x to the 12th y to the negative 4. Once again, I'm going to shift that negative exponent to the denominator. So we have 16x squared over y to the 4th. Going to simplify the 4th root of 16. That is 4 times 4, 2 times 2, 2 times 2. And since we have an index of 4, we need 4 of the same number to make a circle. So I will have a 2 outside of the radical. I have 12 x's, 1, 2, 3, 4, 8, and 12. So that's 1, 2, 3 circles. That's x to the 3rd. Then I have my y's. I have 4 of them, just enough to make a circle. Now, everything in this problem has gotten circled, so it's all been taken outside the radical. However, since the index is a 4, it's an even number, I do need absolute value signs. And so I'm going to put those on any exponents, any variables that have exponents that are odd. Problem 9. It asks us to rewrite this expression in 2 different ways, one as a rational in radical form and one in rational exponent form. So the easiest one to start off with is rational exponent form, because we can take the problem here and rewrite it as a fractional exponent. So 5 over 6. Exponent goes on top, index goes on the bottom. And so we have the rational form, 5x 5 over 6 times x 5 over 6. To write a radical form, we can add the 2 fractions together. Since we're doing multiplication here, we can add the exponents. So we would have 5x to the 10 over 6. We can reduce that to x reduced by 2, so that's 5 over 3. And we can write it as a radical. Now, the exponent is only for the x, so the 5 is not going to go inside the radical. Exponent is 5, so we'll have x to the 5th. Index is 3. So we have 5 cube root x to the 5th. All right, problem 10. Doing the same thing, just a different example. All right, so we can rewrite it in rational exponent form by taking this one right here. We'll have 1 over 4. So now it's written in rational exponent form. And once again, we can actually add the 2 fractions together. However, the denominators are not the same, so I do need to make them the same. I'm going to go do that over here. 2/3 plus 1/4. To make the denominator the same, I'm going to take the denominator of 3 and multiply it to the second fraction, top and bottom. I'm going to take the denominator of 4, multiply it top and bottom to the first fraction. That's going to give me 8 over 12 plus 3 over 12. Those are the 2 fractions I'm going to add. So I have x, 2x, 8 over 12 plus 3 over 12. Remember, you can only add or subtract fractions with like denominators. So now I'm going to have 2x, and then 8 plus 3 is 11 over 12. I can rewrite this as a radical. Now remember, since the exponent is only on the x, there's no parentheses here or anything, that means the 2 is not in the radical. So we have 11, x to the 11th with the index of 12. So this would be our answer for the radical form. Okay, problem 11. Simplify the radical. Use absolute value signs when needed. Once again, this is problem 11. This is not part of the actual question we have to answer, so I'm going to kind of cross it out so I don't mix it up with anything. All right, I'm going to break it down. 81 is 9 times 9. 9 is 3 times 3. 9 is 3 times 3. The 9s are no longer there. Neither is the 81. We broke it down. The index is the invisible 2. This is a square root symbol, so there's index of 2. So I need 2 of the same number, which I've got. I'm going to have 2 3s outside the radical, 1 to represent each circle. I have 11 x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So I'm making circles of 2's, 1, 2, 3, 4, and 5. So I'll have x to the 5th outside the radical. All the numbers got circled, but there was an x that didn't get circled, so it goes inside the radical. 3 times 3 is 9. We have x to the 5th, square root x. Now, our index is even. This is a square root. We do have a variable with an odd exponent, so we do need absolute value signs to ensure that we have an answer that is the principal root. Problem 12. Once again, I'm going to cross out the 12 so we don't mix it up with anything. Okay, we got a cube root. We have 108. So I know that 4 times 27 is 108. 4 is 2 times 2. 27 is 3 times 9. 9 is 3 times 3. Once again, any number that you broke down is no longer there. We have the our index is 3, so we need 3 of the same number to make a circle. We have 3 3's, so we'll have a 3 go outside of the radical. Sadly, we have 2 2's that did not get circled, so they're going to go inside the radical. We have 9 x's, 1, 2, 3, that's 6, and we have 9. 1 circle, 2 circle, 3 circle, x to the 3rd. We have ourselves 11 y's, 1, 2, 3, 6, 9, 10, 11. 1, 2, 3 circles, y to the 3rd. We have 2 y's that didn't get circled, so they'll go inside the radical. Just going to clean it up. We have 3, x to the 3rd, y to the 3rd, index 3, 4y squared. Now our index is odd, so we don't have to worry about absolute value signs. Problem 13. All right, so 96 is 3 times 32. 32 is 4 times 8. 4 is 2 and 2. 8 is 2 and 4. 4 is 2 and 2. Once again, anything that got broken down is no longer there. Okay, index is 4 this time, so we need 4 of the same number. So we'll have a 2 outside of the radical. Inside the radical, we have a 3 and a 2 that didn't get circled. We have 12 x's. And we'll go 1, 2, 3 circles, x to the 3. We have 9 y's. 1, 2 circles. However, 1 y will go inside because it couldn't be circled. All right, we're going to clean up the problem. We have 2x to the 3rd, y to the 2nd, 4th root, 6y. Now we do have an even index. The index is 4, and we have a variable with an odd exponent, so we're going to need absolute value signs on it. Problem 14. Problem 14. So I'm going to cross out the 14 so it doesn't look like it's part of our problem. So this is making us add and subtract radicals. We first look at the radicands. It doesn't look like we can simplify them. So now we want to go ahead and combine like terms. And we combine like terms by everything after the coefficient must be identical to combine them. So as an example, here we have 8x squared square root 5x. I'm looking for another one that has the x squared square root 5x. So the second one, no. Third one, yes. Has the x squared 5x. Those two are like terms, so we can combine them. So we have 8, then we take away 2. We're going to have 6. We're going to have 6x squared square root 5x. And then we have x square root 5x, x square root of 5x, those are the same, so they're like terms and they can be added together. So we're going to have 11 take away 6, that's 5x square root 5x. And since this first one has x squared and the second one just has x, they are not like terms. So this is as simplified as we can get it. Okay, number 15. Once again, we're just going to kind of cross this out. All right, we can want to combine like terms. Once again, anything after the coefficient must be identical. So we have a square root of 7 must match a square root of 7. So those two can be combined. So 4 plus 9, that's 13 square root 7. Here we have the cube root of 7, cube root of 7. Those are like terms, so we're going to combine those. We have a 12 and a minus 2. That gives us 10 cube root 7. Once again, a square root of 7 and a cube root of 7 are different numbers, and we cannot combine those. All right, so this is going to be multiplying two radicals together. This is problem 16. And so we're going to go 2 times 6 to make 12. 15 times 30 is 450. And then once again, when you're multiplying, you add exponents. So that would give us 8. Then I'm going to break down 450 to 15 and 30, which you may notice is right here. Once again, when you're breaking this down, you're asking what two numbers multiply to make 450. It's the two numbers you start with. And then 15 is 3 times 5, 30 is 5 times 6, and 6 is 2 times 3. We do have a square root. So we are looking to make a circle, we need two of the same number. We have two of the same number here, and we have 2 3's, which means outside the radical, I have a 12 that was originally there. I have a 3, and I have a 5 from the numbers that I circled. A number that didn't get circled was a 2, so it's going to stay inside the radical. Then I got to deal with the x's. I have 8 x's. 1, 2, 3, 4. 4 circles, x to the 4th. So now I'm going to multiply all the numbers outside together. 12 times 3 times 5. I have 180 x to the 4th square root of 2. I do have an even index, so I look at my variables and I see there are no odd exponents. So I don't need any absolute value signs, and I've done everything I can for this problem. Problem 17, once again, we're going to be doing some multiplying. So I'm going to multiply the outside numbers. Negative 4 times negative 3 is positive 12. 8 times 12 is 96. Once again, we're multiplying so we can add our two exponents. That's going to give us an 11. I'm going to break down 96 back to the two numbers that I started with. That's 8 and 12. 8 is 2 times 4. 4 is 2 times 2. 12 is 4 times 3. 4 is 2 and 2. Once again, when I break it down, numbers that got broken down are no longer there. We have a square root of 2. We have a square root, which means we need two of the same number to make a circle. So outside the radical, I'm going to have the 12. I'm going to have a times 2 and another times 2. Unfortunately, I have two numbers that didn't get circled, so they have to stay inside the radical. I have 11 x's. All right, and I'm going to be circling two at a time. 1, 2, 3, 4, 5. X to the 5th, and then x left inside the radical because it didn't get circled. I'm going to multiply it all together. 12 times 2 times 2, that's 48 x to the 5th square root 6x. I do have an even index. This is a square root. I do have a variable with an odd exponent, so it gets absolute value signs. 18, we'll be dividing and simplifying. So we're going to start off with our indexes are the same, and since the indexes are the same, I can divide these. So 144 divided by 3 is 48. So I have the fourth root of 48. And once again, when you're dividing, you can subtract the exponents. So 27 minus 3 is going to give me x to the 24. And then I simplify. 48, two numbers that multiply to be 48 is 6 and 8. 6 is 3 and 2. 8 is 2 and 4. And 4 is 2 and 2. Once again, anything you wrote down is not there. But this time, since the index is 4, we need 4 of the same numbers to make a circle. So outside the radical, I'm going to have a 2. Inside the radical, I'm going to have a 3 because it couldn't be circled. I have 24 x's. I could write out 24 x's, or since I can just simply go 24, I can write this as a rational exponent, 24 over 4, that would give me x to the 6th. That's how many circles I would end up having if I wrote them all out. I do have an even index, so I look to my variables. There are no odd exponents, so therefore I don't need any absolute value signs. Number 19, I have the same index, so I can divide these. So 66 divided by 11 is 6. 13 minus 6 is going to give me, I believe, 7. Yep. I'm going to break down 6, 2, and 3. There's nothing to circle, so it's going to stay a 6. So I know inside the radical, I'm going to have a square root of 6. I do have 7 x's. So I can do 1, 2, 3. So I'm going to have x to the third. I'd have x left over. Now I do have myself a even index of the square root, the 2 here, and I have a variable with an odd exponent, so absolute value signs. Problem 20. So this time it's having me doing addition and subtraction to radicals, which means the radicals have to be the same. Once again, anything after the coefficient must be identical to add these things together, but they all look different, which means I probably can simplify these and then add them together. So starting with the first one, I can't break the 2 down, but I do have 8 x's. I can simplify that. So I'm going to write out 8 x's, and then I'm going to simplify it. So 1 circle, 2 circle, 3 circle, 4 circles. So I have 7x to the 4th square root 2. All right, I have a minus sign here and an x. I'm going to bring that down. I'm going to go ahead and simplify the inside. 8 is 4 times 2, and 4 is 2 times 2. Once again, this is a square root, so I only need 2 of the same number to make a circle. So I'm going to go ahead and bring out a 2. I also have 6 x's, 1, 2, 1, 2, 1, 2, 1, 2, 3 circles, x to the third. And there was only a 2 that didn't get circled, so I'm going to leave it where it is. Then I got a minus sign. I'm going to bring that down. I'm going to break down the 48. 48 is 9 times 5. And 9 is 3 and 3. 1 circle. 3 goes outside. The square root of 5 we'll see on the inside. I have 2 x's, enough to make 1 circle, and I write it on the outside. Now I'm going to clean up the problem. I have 7x to the 4th square root of 2. I have a minus. I have a 2. I have an x, and then I have x to the third. It's really x to the first, and if we multiply, we add our exponents. So this is really x to the 4th square root of 2 minus 3x square root 5. Now, once again, anything after the coefficient must be identical to be able to be added. So here I have x to the 4th square root 2. Right here, x to the 4th square root 2. So those two can get combined. So 7 take away 5 is, 7 take away 2 is 5, x to the 4th square root 2 minus 3x square root 5. Now I do have some even indexes, and I notice I have an even x here, but the exponent's a 4, even index here, exponent is a 1. That's odd, so it should have absolute value signs. Okay, problem 21. Perform the operations and simplify the expression. Write your answer using rational exponents. So here, what I would recommend you do is distributive property. So 2 times 9, that's 18. Remember, when we multiply together, we can add the exponents. So 1 plus 3, that's x to the 4th. 2 times 4, that's 8. X to the 1st times x to the 1st, well, that's x squared. So we have the square root of x squared. On the bottom, we have 2x squared. So now I'm going to go ahead and rewrite these as rational exponents since it wants the answer to be in rational exponents, and I'll see if I can do anything else. So I have 18x, I'm going to have 4 over 2. Once again, the index is a 2 here. Minus 8x, 2 over 2. Once again, there's a 2 here. Over 2x squared. I can simplify these, reduce these fractions. So I have 18x squared minus 8x over 2x squared. Okay, so from here, the next thing I can do in my process of simplifying is rewrite these as 2 separate fractions. All right, so 18 divided by 2 is 9. Once again, when you subtract, when you're dividing, 2 minus 2 is 0, so there's no more x's. 8 divided by 2 is 4. And 1 minus 2 is negative 1. So to make it positive, I would need to keep it on the bottom. And now it's in simplified form. All right, factor. So we're going to go ahead and factor this. This is one of our old review questions from way back. We can go ahead and use our box, but I noticed I have a 4, an 18, and a 2. Those are even numbers, so they probably have a number in common. And it looks like 2 would be the greatest common factor, so I can factor out a 2. So 2 times 2x squared would get me the 4x squared. 2 times 9x would get me 18x, and 2 times 10 would get me 20. So I factored a 2 out. I can now use my box to go ahead and factor. So I would have 2x squared here, 10 here, 9x, and then I multiply these two together. So 2 times 10, that's 20x squared. And now I got to figure out two numbers that multiply to be 20x squared, and those same two numbers would combine to give me a 9x. Those numbers would be 4x times 5x, because 4x plus 5x is 9x. So 4x and 5x. So once we have that, we got to figure out our combination, our numbers on the outside. I need two numbers that multiply to be 2x squared. I'm going to go with 2x on top and x on the left. And I'm doing that because I know 2x times 2 would make a 4x. And x times 5 would make 5x. And so 2 times 5 gives me the 10 I need. So now I have 2x plus 2, and then 2x plus 5. And now I have factored the problem.